Yeah.
It's not yet come.
No, it is.
Oh, it's come. It's come now. It has come.
You can see. Yes.
Hi, am I audible? Okay.
Yeah, you are audible, but please give me the access to video and the sharing,
Sure, sure. Give me a moment.
or make me the co-host.
Yes. All right. So good evening. Today we have Professor Sujan Sengupta to talk about why don't we receive signal from aliens? And it's a pleasure to introduce Sujan. Sujan Sengupta is a professor at Indian Institute of Astrophysics, Bangalore, who works on various aspects of observation and theory of extraterrestrial planets. He is a signatory of Breakthrough Initiative for the Search of Extraterrestrial Intelligent Life. He is one of the pioneers of polarimetric method for characterizing the atmosphere of exoplanets. Besides publishing several research papers on exoplanets, he wrote a popular book on the search for habitable exoplanets. So over to you, Sujan.
Can you view me? Can you view my?
Yes, Sujan, we can hear you.
Thank you, Nana, and IIA's outreach team for organizing such an excellent program successfully. Good evening, everybody. I'm sure that all of you are curious about aliens or extraterrestrial intelligent life. Many people even believe in the presence of aliens at the Earth by seeing pictures and videos of UFO or weird animals that suit our imagination of extraterrestrial creatures. But science is a fact-finding process and not based on belief or faith of even majority of people. Science needs unambiguous evidences to establish facts. Testimony of eyewitness is never considered as evidence in science. After 6 decades of hectic search, detected astronomers have not detected any signal or signature that may be considered as communication from or activities of aliens. That's not a failure of our effort, but it implies that such signal is extremely rare. And today I am going to explain you with an analysis of our existing scientific knowledge why an artificial signal or any other evidence implying the existence of alien civilization still remains elusive. That's the Earth, the only planet, our home, in the vast cosmic arena known yet to harbor not only life but also intelligent life and civilization capable of communicating with another cosmic civilization. However, in the 4 billion years of evolutionary history of life on the earth, the oldest ancestor of modern human, the Homo erectus, appeared about 2 million years ago, and the human species known as Homo sapiens appeared only 3 lakhs years ago. Cultivation started about 10,000 years ago, and the oldest urban civilization, the Sumerian civilization, existed only 5,000 years ago. But Sumerians and subsequently Babylonians, Egyptians, the ancient Greeks all were curious about and imagined the existence of aliens and noted down their imagination in paintings, sculptures, and mythologies. People in this ancient civilization believed that intelligent creatures and gods and goddesses they lived in the celestial objects that were visible in the night sky. But about 2.5 centuries ago, Greek scholar and philosopher Aristotle suggested that Earth is a unique place and it was the center of the whole universe. 100 years after the birth of Jesus Christ, Ptolemy supported this geometric worldview of Aristotle, and the Roman Catholic Church adopted this view and decreed that any opposition to Aristotelian view would be against the religion. So thus the plurality of the world was completely lost. But religious hegemony cannot stop progress of science for long. The evidences collected by various scholars started contradicting Aristotelian view. Just before his death in 1543, Polish mathematicians and astronomer Nicolaus Copernicus published his theory that the world is actually heliocentric and the earth moves around the sun. Now, Giordano Bruno openly advocated the Copernican theory. He further suggested that all the lights in the night sky were similar to the sun and they too had planets around them, and some of those planets might have life. For such revolutionary opinion, Bruno was burned alive on the street of Rome on 14th February 1600. In the meantime, astronomer Tycho Brahe collected a large amount of data on the positions and motions of the celestial objects. Based on these astronomical data, Johannes Kepler derived his three laws for motion of the planets around the sun. At the same time, Galileo Galilei, by using newly invented telescope, also observed the celestial objects and discovered the moons of the Jupiter, and he too supported Copernican theory. Thus, the plurality of the world was re-established. The eternal curiosity of mankind about alien rekindled, and we again started asking, is anybody out there or are we alone? But the search, the imagination and speculation of extraterrestrial life were somehow limited to the moon and to the Mars because of technological limitation. The human civilization needed to wait for another couple of centuries before it progressed into a cosmic communicating civilization. After a few years of discovery of radio wave by Hertz, Sir Jesse Bose invented and demonstrated radio transmitter and receiver at Calcutta Town Hall. A few months after that, Marconi too invented radio independently. After about 40 years of this invention, a young engineer at AT&T Bell Laboratory his name is Jansky, invented radio telescope while trying to find out the source of disturbance in transatlantic radio communication. Then an improved version of radio telescope named the Big Ear was constructed for receiving signal from aliens, and the scientific search for extraterrestrial intelligence or SETI began in 1957. A few years later, Frank Drake initiated Project Ojma. So, from Project Ojma to the recently established Breakthrough Initiative, there has been hectic search for 6 decades to detect radio signal from aliens, but without success. So the question arises, does alien civilization really exist in our galaxy? If so, then what should be the possible number of such civilizations that can communicate with us? Even a rough estimation of this number may tell us how frequently we should receive signals from aliens, or we should not at all receive any communication from anybody outside the solar system. An expression for the estimation of the number of communicating alien civilization in our galaxy was given by Frank Drake in 1961. This is famous as Drake equation. This is not a derived equation. The whole purpose of providing such expression was to generate interest on the search of alien. Later on, many researchers presented modified version of this expression, but the main idea remains the same. So here, n is the number of alien civilization that can communicate with us. Rstar, the first term in the left, right hand side, is the mean rate of star formation in our galaxy. Fp is the fraction of star that host planets. Ne is the average number of rocky planets in the habitable zone of the planet hosting of the star hosting planets, and Fl the fraction of rocky planets in habitable zone that actually harbor lives. Fi is the fraction of life hosting planet that harbor intelligent life. Fc is the fraction of intelligent alien civilization that can communicate, and L is the average length of time those civilization can communicate. Now let us discuss one by one How large or small are these parameters? So the first parameter Rstar can be derived from the observed value of the rate of star formation per year, which is currently which is actually the amount of interstellar gas and dust that are used to form stars every year. Dividing this by the mean mass of the newly born stars, we get mean rate of star formation per year in our galaxy. So we take the mean, then we can put R star as 2. The next parameter is the fraction of star in our galaxy that host planets. Now, although Bruno, Sir Isaac Newton and other scholars realized that there could be planets around other stars, a search for such exoplanets were not possible due to lack of technology, mainly due to the unavailability of photographic plates until the middle of the 19th century. The first systematic and scientific investigation was reported by the Madras Observatory's director, Captain William Stephen Jacob. Madras Observatory was established by the British East India Company in 1786. This observatory was shifted to Kodaikanal Solar Observatory in 1900, which becomes part of Indian Institute of Astrophysics in 1971. Now, from the anomaly in the orbital motion of the binary star system 70 OPOC, Captain Jacob inferred the presence of a Jupiter-mass planet as the third component of the binary star system. This was supported by a few astronomers in US, but later on it was found that Captain Jacob did not include the atmospheric effect appropriately. Nevertheless, this is now considered as the first false alarm for exoplanet, and this work motivated many astronomers to search for exoplanet. But for the next 140 years, no planets around stars other than the Sun was confirmed in spite of huge efforts by many astronomers. Finally, in 1995, Michel Mayor and his junior colleague Didier Queloz of Geneva Observatory discovered the first confirmed exoplanet around a star, 51 Pegasi, for which they were awarded Nobel Prize in 2019. But unlike the way we directly see the solar planets, planets around other stars cannot be seen directly because they are hidden under the intense brightness of their parent star. So astronomers use indirect methods to detect and confirm the presence of planets around a distant star. The most popular method through which most of the 4,000 exoplanets are discovered till date is called the transit method. Now, in this method, astronomers continuously monitor the brightness of a star. If the star hosts a planet which orbits edge on with respect to the observer, then it blocks a tiny part of the stellar disk and hence reduces the brightness of the star periodically while crossing the star. Such periodic changes in the brightness of the star implies the presence of a planet. Now, a statistical analysis of the number of exoplanets detected by using transit method indicates that about half of the stars in Milky Way galaxy host a planet or a planetary system. But this method can detect only those exoplanets that orbits almost edge on with respect to the observer. By using Indian telescopes, we too observe the planet hosting stars through transit method and detect signal of the exoplanets. Another detection method based on the principle of Albert Einstein's general theory of relativity can avoid the bias inherent to transit method. This method is known as gravitational microlensing method. If a distant star is almost exactly aligned with a nearby star and the observer, the nearby star acts as a lens magnifying the light of the distant star. This happens because the light of the distant star bends by the gravitational field of the nearby foreground star. Now, if the foreground star hosts a planet, the planet also acts as a lens. Now, by monitoring the magnification of light of the distant star, an exoplanet around the foreground star is detected. The statistical analysis of exoplanets discovered by using this method implies that all stars have by average one planet. So hosting planets is a normal property of stars, or it's a general rule. The next parameter is the average number of rocky planets in the habitable zone of a planet hosting star. But then what is habitable zone? Circumstellar habitable zone or Goldilocks zone is a region around a star that is located at such a distance from the star that the temperature of the region is appropriate for water to exist in liquid state. Clearly, the distance of this zone from the star depends on how hot the star is. Now, if we consider only the brightness of the heat emitted by our sun, then the surface temperature of the Venus should be about 55 degrees Celsius. The surface temperature of the Earth should be about 5 degrees Celsius, and that for Mars will be minus 47 degrees Celsius because Mars is far away. Therefore, Venus, Earth, and because of an elliptical orbit, marginally Mars would be appropriate, will have appropriate surface temperature for water to exist in liquid state. But we know all planets have a reflecting property called the albedo. 30% of sunlight received by Earth is reflected back to space. Mars reflects about 25% of sunlight, and Venus reflects a whopping 75% of sunlight it receives on its surface. So if we consider the reflectivity or albedo, then the surface temperature of Earth would become about minus 18 degrees Celsius. Temperature of Venus will reduce to minus 43 degrees Celsius, and the surface temperature of Mars would have been minus 63 degrees Celsius. As a consequence, none of the planets in the solar system could be habitable. But we know water on Earth exists in all three states, as the mean surface temperature of Earth is about 15 degrees Celsius. So why? What makes the Earth warmer? That's because of the greenhouse effect. Now, part of the visible light from the star gets absorbed by the solid surface, and the surface warms up. The warm surface re-radiates in longer infrared wavelengths. This comparatively weak radiation of longer wavelengths while trying to escape the planet gets scattered several times by water, carbon dioxide and methane molecules in the atmosphere and hence get trapped. The trapped radiation increases the atmospheric temperature. Earth's temperature increases by about 30 degrees due to greenhouse effect. Since Mars has a very thin atmosphere, the greenhouse effect alters the temperature very little by about 5 degrees. On the other hand, presence of 95% carbon dioxide in a very thick atmosphere of Venus causes a runaway greenhouse effect that raises its temperature to 464 degrees Celsius, making Venus the hottest planet among the solar planets, although Mercury is the nearest planet. Thus, even if a planet is located in the habitable zone of its parent star, the nature of the planetary atmosphere determines if it can have ambient temperature appropriate for water to exist in liquid state. Now, quite a few rocky planets in the habitable zone of their host stars are detected till date. Analysis of data obtained by NASA's Kepler Space Telescope indicates 2 to 12% of stars, mostly the smallest and the faintest ones in our galaxy, have rocky planets in their habitable zone. About half of sun-like stars should have a rocky planets in the habitable zone. So, the average number of rocky planets in the habitable zone of planet-hosting star could be at least 1. But can all these rocky planets in the habitable zone really harbor life? That leads us to a more fundamental question: what is life? Now, our understanding on life is based on the billion of living species we know on the Earth. But can we define even Earth-based life? When I search for the definition of life, I stop counting up to the 95th definition of life, and that excludes the philosophical definition. So, there is no universal definition of life. If someone asks you what is water, you will reply that it's a molecule made of 2 hydrogen atoms and 1 oxygen atom. It can even be expressed as a formula H2O. By applying our knowledge on atomic and molecular physics and a little bit of quantum mechanics, we can derive all the physical and chemical properties of water from this formula. However, such a fundamental formula for life doesn't exist, and so we can only describe various essential functions that distinguish a living species from a non-living one. Basically, life is an ensemble of organic materials governed by a self-sustaining synchronized system of chemical processes and characterized by metabolism, replication, and evolution through natural selection. Now, organic molecules are compounds made mainly by carbon, oxygen, and hydrogen. The origin of organic materials on Earth is a controversial topic. About 90 years ago, two scientists, Oparin and Haldane, postulated that organic materials were synthesized on the Earth out of the available inorganic materials under some conditions that prevailed during the early epoch of the Earth. After 20 years, that is about 70 years ago, Urey and Miller, two scientists, synthesized amino acid, the building block of life, in laboratory out of a mixture of inorganic materials by simulating the conditions similar to that prevailed during the early period of the Earth. The result of this experiment convinced people that life originated on the Earth itself through chemical evolution. But recently, we have discovered various kinds of organic materials, including nucleic acid that is present in living species, being imported to the Earth by meteoroids, such that this meteoroid that is there in the this is 7 billion year old. As the infrared astronomy progressed, we also discovered that the interstellar medium is a huge factory for producing organic molecules. Interestingly, Urey-Miller experiment and future upgraded experiment produced only one out of the 20 types of protein-making amino acids present in any living species. So there is a controversy and difference in opinion about the origin of life. Did life originated on the Earth through chemical evolution, or had it come from the space? Nobody knows for sure. But if the origin of life is cosmic, then there must be many exoplanets that harbors nascent life or microbes. However, most of the biologists consider that biological evolution on the Earth was triggered by chemical evolution. Under special conditions, molecules of ribonucleic acid or RNA were formed which can store information. Then it evolves to ribosome that can both store information and catalyze protein formation. So if that was the case, then origin of life might be a coincidence and could be quite rare. The puzzle will be solved only if living cell can be synthesized in laboratory. Anyway, metabolism is a biochemical process through which a living cell receives, stores, and releases energy in its battery called mitochondria. Hydrolysis and oxidation are two important chemical processes of catabolic metabolism or catabolism, through which large molecules break into small molecules and releases energy. Therefore, liquid water and oxygen molecules are essential for life to continue this metabolism or energy supply process. Of course, liquid water is also essential for photosynthesis by green plants and some bacteria that acquire solar energy directly and store it in glucose molecule produced from water and carbon dioxide. Animals cannot acquire solar energy directly, and so they eat plants and consume the glucose. Hence, the habitable zone of a star is defined as the region where liquid water should be there. Now, replication is a process through which a living cell makes an exact copy of itself and also transfer genetical information from one generation to other. Evolution is the response of an organism to the environment and the consequence over long periods of time. If we find a cat or dog in another planet, we can infer that the planet has several cats or dogs and their progenitors. But if we don't, we can safely infer that the animals were imported from other planets. However, a description is never complete and many a times controversial. So for astronomical search for life, NASA has provided us a working definition for life, and that says that life is a self-sustaining chemical system capable of Darwinian evolution. So even if we assume that life may origin in all rocky planets in the habitable zone of the host star, survival of life requires several favorable conditions. An extremely rare combination of astronomical and geological coincidences enables life on the Earth to survive and evolve. The solar system is configured in such a way that it protects life on Earth from frequent collisions of comets. The short period comets are born in a disk-like region filled up by ice and rocks at the edge of the planetary system. This region is known as Kuiper belt. On the other hand, the entire solar system is surrounded by a spherical gaseous region called the Woods cloud. Long period comets are born here. Now, many of these short and long period comets could collide with the Earth while they orbit in a highly elliptical orbit around the Sun. In our solar system, the small rocky planets including Earth are located near to the Sun, and the giant gas planets such as Jupiter and Saturn are orbiting far away from these rocky inner planets. Now, because of the strong gravity of these giant planets, most of the comets coming from Wood cloud or Kuiper belt are attracted towards and collide with Jupiter and Saturn. Thus, the rate of collision by comets with Earth reduces significantly and the Earth is protected. Now, the Sun occasionally flares up, throwing out a large amount of energetic charged particles. These charged particles cannot penetrate our atmosphere because the Earth has a dipolar geomagnetic field. The little amount of charged particles can enter the atmosphere only through the magnetic poles, causing the spectacular aurora. So if there was no geomagnetic field, the energetic charged particles could enter the Earth in all directions, causing chemical changes in the atmosphere and would destroy the living cells. Now you will be surprised to know even earthquake and volcanoes are also protecting life on Earth. Carbon dioxide in Earth's atmosphere plays double role. It reflects a good amount of sunlight to space, making the Earth cooler. At the same time, it acts as an effective greenhouse effect to keep the Earth warm. So a balanced amount of carbon dioxide needs to be present all the time. But carbon dioxide mixes up with rainwater to form carbonic acid, and it dissolves into silicon rocks to form carbonate sediments. Under such process, the atmospheric carbon dioxide would have been completely depleted in 10 million years, making the planet much cooler. But because of active volcanoes and earthquake, carbon dioxide is released again into the atmosphere, keeping a balance in a million years. This is known as carbon-silicon cycle. Volcanoes and earthquake also reprocesses the minerals and the gases in the earth. Therefore, geological activities help in maintaining a habitable environment on the earth. Now, the spin axis of the earth is at present tilted at 23.4 degrees with respect to the normal to the orbital plane. This tilt causes seasonal variation on the earth. But this tilt angle or obliquity is not fixed. It varies from 21.5 to 24.5 degree in 41,000 years. Earth's orbital shape and plane also changes in 1 lakh to 4 lakh years. These dynamical changes are small enough to enable the planet to have a stable climate over a long period. And this is possible because of the presence of a large moon or our beloved moon. The moon formed from the ejecta of a collision between the primitive Earth and a Mars-sized object called Theia about 60 million years after the birth of the Earth. Before the moon was formed, the Earth was spinning so fast that a day was less than 10 hours long. The moon slowed down the spin and helped the Earth to maintain a small tilt angle through a tug of war with the gravitational pull of mighty Jupiter and Saturn. Therefore, moon not only causes tide and atmospheric circulation, but also prevents a chaotic seasonal change and helps the Earth to maintain a favorable climate for life on the Earth for a long time. However, we may never know if an exoplanet is lucky enough to have so many favorable geological and astronomical conditions that support life. Therefore, in order to find out the fraction of habitable planets that actually harbors life, we need to search for signature of life itself or biosignature in the atmosphere of these planets. Now, we can detect the atmospheric composition of Venus, Earth and Mars by passing the light through an instrument called spectrograph on board a space telescope. The spectra obtained from these three planets shows the presence of carbon dioxide in the atmosphere. But in addition to that, the spectrum of the Earth clearly shows signature of water, oxygen and ozone molecules. Now at the initial stage, Earth did not have any free oxygen molecule because all the oxygen atoms combined with other elements to form oxides such as water, carbon dioxide, silicon oxide, etc. About 3.9 billion years ago, a bacteria called cyanobacteria appears on the Earth, which through photosynthesis produce great amount of oxygen molecules, and the chemical composition of the Earth's atmosphere was drastically changed. So the living species which was lived by without oxygen, oxygen become poisonous to them and they all extinct, and only those species which could adjust with oxygen survive. These oxygen molecules get dissociated into oxygen atoms by solar ultraviolet rays at the upper atmosphere. One oxygen atom then combines with one oxygen molecules to produce ozone molecule. The ozone layer formed in this way at the upper atmosphere of the Earth is protecting us from the intense ultraviolet rays of the sun. Therefore, oxygen and ozone molecules serve as biosignature. Methane also serves as biosignature in an oxygen-rich atmosphere. Chemically produced methane cannot survive for a long time in the Earth as it reacts with oxygen to form carbon dioxide. But the equilibrium in such chemical reaction breaks down if methane is produced biologically. Thus, signature of methane serves as biosignature. However, obtaining the spectra of a habitable exoplanet is not straightforward, as the reflected light from exoplanets cannot be seen directly. So, to obtain the spectra of exoplanet, first the spectrum of its host star is taken when the planet is not transiting or blocking the light. Then the spectrum is taken during the transit epoch. Since a part of starlight passes through the atmosphere of the planet, this spectrum carries signature of atmosphere of both the planet and its present star. Now subtracting the first spectrum from the second one produces the spectrum of the exoplanet. This is called the transmission spectra. We numerically model such spectra that can be compared with the observed transmission spectra and can recognize biosignature if present in the atmosphere of those planets. Unfortunately, presently available observational facilities are not sufficient to obtain transmission spectra of rocky exoplanets in habitable zone, but the recently launched next generation space telescope, James Webb Space Telescope, is expected to obtain the much desired transmission spectra of habitable rocky planets. At the same time, we will soon get three giant ground-based telescopes, European Extra Large Telescope, 30-meter telescope and Giant Magellanic Telescope. With the help of such powerful next generation telescope, we hope to detect biosignature in some exoplanets during the present decade itself if life really origins and survives on other worlds. Now coming back to our estimation on the number of intelligent civilizations that are capable to communicate. Right now, we have no idea, not even a rough estimation or a reasonable guess on the fraction of planets that harbor life. The next two parameters strongly depends on this parameter, the fraction of rocky planets in habitable zone that harbor life. Now, if we assume that life originated anywhere would definitely evolve into intelligent life, then the fraction of life hosting planets that harbor intelligent life should be 1. But evolution may not be so deterministic, and the evolution history on other planets may not necessarily be the same as that of the Earth. such that intelligent life would certainly appear at some stage on a life hosting exoplanet. However, it will not be illogical to consider that if intelligent life appears in some exoplanets, it may, due to its nature and own necessity, will progress into a advanced civilization like us and ultimately would be capable to communicate with other alien civilization. Now, note that out of several species in the genus Homo, only Homo sapiens or humans survived, and it is the only species on the earth that is intelligent enough to communicate with others in the universe. So, the presence of communicating civilization on the earth makes the product of these three factors non-zero because we have at least one such planet. But we don't know how small or large it is. Two extreme cases arises. Even if we consider that the origin of life is quite common in our galaxy, but an exoplanet needs the extremely rare coincidences of all the favorable conditions that enable life to survive on the earth, then the number of alien civilizations that can communicate will be extremely small. Possibly we are the only such case in our galaxy. This is known as rare earth hypothesis. On the other hand, if we consider that life may somehow manage to survive without these favorable conditions that our planet enjoys, then the number could be several millions. In fact, some living species on the earth called extremophiles can survive under extremely hostile conditions. But these microbes cannot evolve into complex or developed species under extreme conditions, let alone evolving into intelligent life. Now, in estimating the number of alien civilization capable of communicating with other in our galaxy, the last parameter L, which is the average duration that alien civilization, if any, can continue communicating, is overestimated in the principle of mediocrity. I shall discuss it in the last slide. Space, although is vast, empty place, it is often a dangerous place. Although the giant planets Jupiter and Saturn are protecting us, but a few comets may escape their clutch and hit the Earth. Collision by a comet or a giant asteroid would cause evaporation of the oceans, block the sunlight by forming a thick dust cloud, and even may alter the spin rotation angle of the Earth. Collision by a comet about 60 million years ago is believed to be responsible for the extinction of dinosaurs. Supernova explosion at the last stage of evolution of a nearby heavy star or just one gamma ray burst in our galaxy, the most powerful source of energy in the universe caused by the collision of two neutron stars, may destroy Earth's biosphere permanently by intense X-ray and ultraviolet rays. The Sun is a gentle middle-aged dwarf star without much activity. But if due to any unknown reason a strong activity in future, it emits a giant flare, the geomagnetic field may be permanently destroyed, causing energetic charged particles from the Sun to penetrate and damage the biosphere. There could be geological disaster as well. A super earthquake or a super tsunami or gigantic volcanoes may cause extinction of developed life on the land. Although the possibility of the occurrence of such astronomical and geological calamities is very small, mass extinction on this planet actually occurred at least 6 times in the past. But the most imminent threats may come from human civilization. It's a man-made disaster. An accidental nuclear, chemical or biological wear may completely destroy the entire human civilization and cause irreversible damage to the biosphere. Rapid expansion of industry and use of fossil fuel may increase the amount of carbon dioxide in such a great extent that the carbon-silicon cycle may be destroyed. Global warming can cause hole in the ozone layer and hence protection from solar ultraviolet radiation may break down. So, the progress in civilization with irresponsible use of technology may cause destruction. All these astronomical and geological and man-made potential disaster can cause the duration of communication by our civilization or any similar alien civilization could be made quite short. Hence, the number of cosmic communicating civilizations in our galaxy may reduce significantly by destruction. But whatever be the possibility of the existence of alien civilization, whatever be the number of advanced civilization, the fact is that till date we have no evidence, no signal, no signature of life anywhere outside the earth. Believe it or not, no signal yet from aliens, no signature of any unnatural activities even at the farthest part of our galaxy implies that we are alone in this vast cosmic arena. Accept it or not, we have no place to migrate, nobody to help from anywhere if global disasters strike us. Our home, the planet Earth, is so special yet so vulnerable, so crowded yet so lonely, so common yet so unique, so insignificant yet so great. We all are in the same boat, a mote of dust suspended in the beam of sunlight and floating in the vast emptiness of space. We must not allow our ego, our ignorance, and our irresponsibility to sink this boat. So, irrespective of our caste, creed, country, it's our duty, it is the responsibility of each and every member of our species to protect this rarest of the rare planet so that generations of children can keep on smiling.
We are in the same boat, brother. Same boat, brother. We are in the same boat, brother. We are the same boat, brother. If you tip one and you're gonna rock the others, the same boat, brother. Oh Lord, look down. Holy place. Oh Lord, me. What a serious space. What a place to learn. Does human race. So he built him a boat with a mixed-up crew, with the eyes of black and brown and blue. That reason you and I have just one more than just one star. We are the same boat, brother. The same boat, brother.
Thank you, Sujan. Thank you for such an excellent talk. I'm sure that there will be many questions from the audience.
No problem.
So first, whoever has a question, please raise your hands. I can call one by one so that you can ask your questions to the speaker. And I will also read the questions which appear in our YouTube channel. And I request the audience to stick to the questions which are relevant to the talk, please. All right. So you may also unmute your mic and ask the question.
Hi, Sujan.
Hi,
Anyway, it's a great talk.
thank you.
So I just wanted to know about this. What is this L is equal to 300 and L is equal to 1 billion year thing?
That is the length of the duration through which civilization can communicate, can emit radio emission. So if it is not lengthy, if it is say less than that, then we cannot receive it because it goes at maximum speed of light only. But if it say they can continue for 1 billion years, then more and more possibility will be there to detect them. So some of the people think that no, our civilization cannot last more than 300 years, so it will destroy itself.
Yeah,
But some
yeah.
people tell that once you discover the communication process, then at least 1 billion year it will continue. But see, the thing is that that is very, very generic, because we know that every 1 billion year the sun's brightness increases by 10%. So the sun's temperature will become much higher within at the end of 1 billion year. But maybe somehow the civilization can adjust that. So that's a possibility also. But these are all to give the extreme end of the calculation, means the estimation.
Mhm.
One is by taking the minimum possible way, and another is taking the optimal possible way.
Okay. Thank you.
Any other questions? Please unmute yourself and ask. We do not have any questions in the YouTube chat yet. Sure, sure.
I understand properly. You want to say that if life elsewhere can be made by some other material, or the biochemistry. Yeah, but in ocean there is nothing which are not made of organic material or carbon based. Everything is carbon based. We cannot have a silicon based, and now I am explaining it for that. So, okay, first of all, start with that. If we don't see anything, that doesn't mean that there will be something different or something weird. The second thing is that the laws of physics are universal. It is proven that the laws of physics are universal in the whole universe. So Newton's law, Einstein's law, Faraday's law, Maxwell's law, Kepler's law, all that applies to this corner of the universe is valid in the end of the other corner of the universe. So consequently, the laws of chemistry will also be the same everywhere. So there is no, it is not will be very logical to consider that the biochemistry will be different in other places. The third point is that carbon is the fourth most abundant element in the universe. So nature always preferred to have the optimal conditions. Now carbon has the properties that it can combine with several elements to form several molecules which other elements cannot do. For example, see, silicon has similar chemical properties of carbon, but its bonds are very fragile. Even the double bond of silicon is extremely fragile, and there is no analogy of carbon dioxide such as silicon dioxide or such type of thing there. So the thing is that why means how the biochemistry will work, that we do not know, and so I think that wherever there will be life, that will follow the same chemistry, that will follow the same biochemistry, and that will follow the same composition. But if still we speculate that life could be in other form anywhere, then there will be no way to recognize them as life unless and until it is an intelligent life and that inform us that looks, I am also life but not made of carbon.
All right. So we have a question in the YouTube chat. So I'll read it out. What is the energy harnessing equivalent of an advanced multiplanetary civilization? And how do we reach such a magnitude?
No, I'm not. I didn't get the question. What is the question? It is the energy needed to travel to us, or the energy needed by a civilization to become civilization, or what is the? Can you explain the question?
Actually, it is written as what is the energy harnessing equivalent of an advanced multiplanetary civilization? Maybe to sustain.
There is nothing. See, the thing is that in the Earth, it needs about 10 to the power 13.5 arc per second per watt, that energy. But with the civilization, it. So I think the person who has asked, what is the name of the person asked it?
Kiran Murthy.
Okay, so I think he or she is asking about the Kardashev classification of civilization. So Kardashev categorized, this is a highly speculation or hypothesis, the three category of civilization. Civilization 0, that can use all the energy from its star that is received by its planet. Civilization 1 is the one which can extract the entire energy of its star by putting a Dyson sphere type of thing. Civilization 2 is a civilization that is capable of extracting the energy produced by the entire galaxy. So it can control the entire galaxy. And the civilization 3 is just like very similar to God, that it can control the whole universe. So now this depends on the energy requirement. For Earth requirement, we are not even civilization 1, we are less than that, because we still use fossil energy, and we cannot even use nuclear fusion for our need of the energy. So let alone using the entire solar energy that is received by us. And so, but still we are able to means initiate our civilization 5,000 years ago. Still we have the technology to communicate with alien civilization, because we have discovered a radio receiver and transmitter. So the minimum temperature is not very high to become a cosmic communicating civilization. So Earth is even less than 1. So even Carl Sagan has given a formula to express Kardashev scheme, the Kardashev classification. So according to that, the Earth is a 0.17 or 0.16 civilization. But these are all speculation. There is nothing to worry about all those things, because until and unless we discover biosignature, we are confirmed that life exists elsewhere. Unless and until we get a signal from an intelligent life and confirm that intelligent civilization exists elsewhere, there is no need to speculate such type of energy harnessing civilization.
Okay, so Vagesh Mishra had two questions. So Vagesh, would you like to unmute yourself and ask?
Yeah, so hello, it's very nice talk. So actually, my question is probably answered, but I would like to tell in another words. So, like, can there be a life for which we cannot understand that in terms of biology, which we know now? So, something called exobiology, but other than the way we understand biology. And my another question is that, do we have consensus on what do we mean by intelligent while searching the life?
Yes, so we have some consensus on what is intelligent life for the astronomer at least. See, of course, if we ask that who is the most intelligent species on the earth, we will unambiguously answer that it is the human being. But then some biologists will tell that the dogs and cats are also intelligent, dolphins are also intelligent. Even environmentalists will tell that the ants are also intelligent. But unless and until a species evolve in such a way that it can emit, or it can produce or transmit or receive radio signal, no alien life from outside can detect us. They cannot get our communication. So the civilization, at least one species has to, has to be capable of producing artificial electromagnetic signal, transmitting it and receiving it. If we can't receive, even there are 1 million intelligent civilization, but if their signal came 10,000 years ago when we didn't have any development for receiving them, then we have missed it. But of course, that is not the case. If the intelligent life will send the signal, they will continuously send the signal, or automatically our artificial signal will penetrate the ionosphere and go everywhere. Our radar signal, our TV signal, our mobile signals, our even all kind of source of radio signals are going to the outer space, and they may be intercepted by intelligent civilization if there is any. But we have discovered this radio only 120 years ago. We have invented the transmitter only 100 years ago. So in that year, this artificial electromagnetic wave has traveled only 100 light year. So if the intelligent civilization is beyond 100 light year, it has not yet received this signal, and they cannot recognize or they cannot detect our signal from that. Okay, Naina?
Yes. So we have another question in the YouTube chat from Shailaja. So the question is, a mere 5,000 years has given rise to a vast difference in our technological capability. That such a short duration can have such a large effect. What does this imply for probability of detection of signals?
Yes, that's a very good question. Actually, our technological development is not even 5,000 years old. It is just few thousand years old with the Renaissance in the Europe, with the Industrial Revolution in Europe. So it is just a few hundred years ago. So imagine that about 120 years ago, there was no radio. Forget about mobile phone, internet or anything else there. So, but this may imply that even if we are not the only life on this galaxy, we may be the first civilized species on our galaxy, because the Earth was born 4.5 billion years ago, and human species itself has come some few 100,000 years ago. So the Homo erectus came a few lakhs years ago, and the Homo sapiens appeared in Africa about 200,000 or 3,000 years ago. So from that it started evolving, and in the same time what happened, the human brain also started evolving. So the brain, and the human brain has a special capacity. I think Yogesh asked that what is the difference, something like that, in the intelligence. So the brain, our brain is actually distinguishes us from other animals. So usually what happened, when any living species encounter an event or an object, it becomes curious. So it uses all its organs to identify or to get an explanation of this event or that object. But all the species except the human being, their curiosity stops if this event or if the object is not linked with their daily life, their food or their security, etc., and their curiosity dies. But human brain is a special cases where it stores, where it, even if it fails, it all organs fails, it uses the stored memory to try to analyze it and to get an explanation. So human art has a higher capacity of storing memories. At the same time, it has some property which is unique to the human only, that is called imagination or speculation. So with this imagination, the technological imagination and then implementation, all those things, with that we the human species developed into the advanced civilization, and thus the technological revolution was possible.
Now Mihir has a question. Mihir, can you please unmute yourself and ask?
Yes, can you hear me?
Yeah.
Yes.
First of all, good and blessed evening, sir and ma'am, and to the entire IIA. It was really wonderful to, have here. The question which I had was that it's like three in one. So, would it be possible to have human civilization in some other dimension? And will it be that aliens, what we like say and think of you,
At least I
current
don't.
humans, like
I have no idea about. I know only three dimension, but I believe in fourth dimension. Okay, so if time is considered, then we are in fourth dimension. But if there is any higher dimension or anything, so this question I asked to the general relativist whether this wormhole and all those things are really possible. So and Professor, I think some famous general relativist told that classically it is possible, but quantum mechanically it is not possible. Once you enter or anything entered into a black hole, like in the interstellar movie, so it will be quizzed and it will be become such a small thing that it needs the quantum mechanics to describe that states, and quantum mechanics doesn't allow this wormhole, and therefore there will be no chance for coming out in other direction or in other dimension. So these are all imagination or science fiction only.
oh, and just one more question that will plant and animal vegetation thrive in outer dimensions since it's believed that we are stardust and that we have come from space?
Sorry, can you repeat the question?
Will plant and animal vegetation thrive in outer dimension since it's believed that we are stardust and that we have come from space?
Yeah, actually, what happened, what I mean to say that not the plant or life has come, some seed of life, say the ribosome or the ribonucleic acid, that has traveled and that has put in everywhere. Now, wherever it has got a favorable environment, it started evolving and it survived. So it is not that some cats and dogs came from space or something like that. It is the nascent life, even not the nascent life, even the seed of life that was produced in the space, and that survived because that was nothing. There was not much difference between is a molecule and the biomolecule. So it originated from in the space and then traveled to some planets and then initiated the abiogenesis.
Okay, sir. Thank you very much.
Okay, there is a question in the YouTube chat from Dr. Salil Gupta. The question is, what about intelligent life based on robots, AI robots, or hybrid life replicating themselves?
Yes, so if there are artificial life or robot or something, then naturally the possibility of getting signal from those type of life will increase by several fold, because now it is not even the living species, it is the robot. So even if the civilization destroyed or the robot survives, they will continue, and so the number of cosmic communicating civilization, although it is not cosmic civilization or living species, that will increase, and our probability of getting a signal or some activities happening somewhere will increase. But we still don't get any signal or anything. But now if we get such type of signal, we cannot recognize, or we may not know that whether it is a living species or it is a robot, unless and until that guy says that look, I am not a living species, I am a robot. So but if such type of thing exists, then the possibility of getting a signal, artificial signal from the space will increase in several times, and even you have to modify the Drake equation so that some other factor has to be included, so that which will increase the possible number of then we have to tell not the number of cosmic communicating civilization, we have to tell the number of communicating planets or communicating place in our galaxy or in the universe.
Okay, next question. Hasnain Koser has a question. Can you please unmute yourself and ask?
Good evening, sir. So thank you for the great talk. I had also attended your talk in 2019 at IUCA. So I had this question, whether the inclination of the exoplanet orbit affects its habitability.
Sorry, you're not clear. What is the inclination angle?
Inclination of the orbit of exoplanet, if it does that affect the habitability?
No. That doesn't affect anything. That affects our detection capability only. It doesn't affect the thing. That's why I have told that the gravitational microlensing method, it can detect any planet with any inclination angle. Even if we detect whatever planet we have discovered through gravitational microlensing, we neither know their radius nor we know their inclination angle. But they may be, some of them may be habitable, because gravitational microlensing has the capacity to detect even the farthest planet. So whereas the transit method cannot detect, actually it needs a powerful, bigger, larger telescope to detect the further planets. But inclination angle or any orbital things doesn't need to. But the habitable zone will affect if the planet has an elliptical orbit, or if it is tidally locked, like most of this rocky planet in the habitable zone of M dwarf star, the faintest and the coolest star we have discovered, are so near to their star that they are tidally locked. Tidally locked means it's one side is always facing the star and another side is always in the opposite direction. Therefore, their environment may not be habitable, because there cannot be much circulation of temperature, and those will not be really habitable planets. So the actual search has to be done in the habitable zone of sun type of stars. But in any case, unless and until we invent some method through which we can probe the planets that are not orbiting with high inclination angle, we can increase the probability. So polarimetry is one of the methods that I pioneered. I have suggested that through the polarization, one can detect the composition of the atmosphere of exoplanet which is orbiting even with smaller inclination angle. So in USA and in other places, this method is now being used to detect the polarization. But of course, this needs much larger or next generation telescope and much complicated instrument. But we'll do it.
Sir, I also wanted to know if super Earths were habitable, and how gravity plays a role in the habitability.
Yes, super Earth could be even super habitable. See, what is super Earth? Super Earth will be at least 1.2 to 1.5 times larger than the Earth, and it could be 5 times to 6 times heavier than the Earth. So its surface gravity will be slightly higher. In that way, the atmosphere will be bigger. On the other hand, there is one kind of planet that is called ocean planet, that is also giant planet. So super Earth, what happened? Either the rock, the extension of the rock will be larger, or the atmosphere will be larger. But super Earth in the habitable zone could harbor life. When you ask this question, I should mention you of our recent work. Now we are doing it. So if there is a gas giant planet, if there is a Jupiter-like planet in the habitable zone of a star, it may not have a life on it, but a rocky moon orbiting it may have life on it. So very recently we have submitted that how to detect this rocky exomoon. We have submitted this paper, and it's in progress. How we can probe the atmosphere and how we can detect a rocky moon around a gas giant in the habitable zone of a star. But in my discussion, I have not discussed today about the exomoon. That is the future. That's still elusive. We have not yet discovered any moon orbiting any exoplanet. Although we know that in our solar system there are hundreds of moons, rocky moons of different size, from Deimos, Phobos, like small satellite, to Ganymede, Titan, Triton, and our moon itself is a great object. We are very lucky to have our moon. So that that motivated
গবেষণা না হলে তো এই জিনিসটা আসতো না।
Aditra, please mute.
Can you mute yourself, Aditra? Yeah, thank you.
So what I was talking, I just forgot it. So the thing is that we are working on this, all those things. The future, we are getting many large telescope, and I'm very hopeful that James Webb Space Telescope within a couple of years will provide us great discoveries, maybe biosignature from some rocky planets. And if that is discovered and confirmed, then it will affect our entire civilization. It will tell that we are really not alone, and the origin of life is really cosmic. It is not confined within only one planet in the galaxy, at least.
All right, Sujan, we will take one last question from Vagesh. He has one more question.
Okay.
Yeah, so actually the very basic question, like I am like aware that lot of projects are there which have tried to look life, try to communicate interstellar space using microwave or radio wave. So my question is that even if we receive some signal which is like new, so how can we actually filter out that this is not from some sources in space? Because there are a lot of signals which we might not have detected. So how to know that is created by some intelligent life? Just please want your comment.
Vagesh, I think you should have attended yesterday's talk by the breakthrough person. What was his name, Naina? Yesterday,
Vishal Gajjar.
Vishal Gajjar. So he gave a detailed reply on this thing. So I think you will get the answer if you just watch the YouTube, the recorded video. So he has told that, what if I remember properly, that all the natural sources, radio sources, are broadband, and the signal from extraterrestrial intelligence will be extremely narrow band, within 1 hertz even. So that is one thing, and there will be periodicity, or there will be some what is that? There is some pattern in their signal. So there are many things he mentioned about how to filter out those signals and how to get it. But the most important characteristic of the signal of extraterrestrial life will be the extremely narrow signal, extremely narrow radio wave within even 1 hertz from it, which never produce in any natural or any astrophysical object or phenomena. Now the thing is that why it will be so narrow band? Because nobody will try to spend so much energy. It needs a huge amount of energy to produce a broadband signal. So that's why we expect even our signals are also very narrow band. So if our communication, if our radio signal is received by any nearby civilization, if they exist, of course always I emphasize if they exist, then they will get only in narrow band, which is completely different than the natural sources. Natural sources means astronomical sources.
Thank you, got it.
All right. So thank you very much again, Sujan, for such an insightful talk and for addressing all the questions which we had both on Zoom as well as in the YouTube chat. Thanks again. And this event is the last event among the series of events that we were conducting as part of National Science Day Celebration 2022. So I thank all the participants who are here and also who are watching online for their active participation and for making this event a grand success. Thank you very much.
Thanks
Thank
to the
you, ma'am.
outreach team. It is an excellent program you have organized, and it's highly successful. It's all the kudos to you all, and we hope that we will continue in IIA such type of program in future. So congratulations all the members of the outreach committee for having a successful outreach program.
Thank you very much.
Sir, is Sir there? Yes,
Sorry?
left. Is Sir?
Ishwar has left.
Okay.
Thank you. So we are closing the session.